Oh my goodness. Hello, everyone. Welcome to .NET Unboxed. James is out of the country, so they left me in charge. Let's see what I can mess up here. I am happy to be joined today by Dan, Chet, and Joel with some amazing things, including a cool surprise that Joel's going to wrap up with at the very end. So welcome, folks. All right, I guess we'll just get right into it because I don't know what I'm doing. So I'm going to kick Chet and Joel out of here, and you'll hang out backstage. You're not totally off the hook, and we'll get going with Dan's stuff. So Dan.
Yes. Hello. How's it going,
Overachiever, showing up with some slides. What do you got?
I know. Some of these things are a little harder to show other than in like massive hyperscale production environments, but they're still pretty cool. So I thought we would share them. Yeah, let's want to talk a little bit about the new ASP.NET Core features in .NET 10 Preview 6. It's now out the door. It's available to be downloaded, which is great. It's a pretty packed release. Yeah, so I'll just go ahead. Is that
I will disappear. You go for it.
All right, sorry. Okay, cool. Yeah, so first of all, one of the great new improvements in .NET 10 Preview 6 is that Kestrel, our built-in HP server, is now much smarter about how it handles memory. Kestrel, in its innards under the hood, it will pool memory to avoid allocations, and it grows its memory pool as needed based on whatever load it's currently under. But previously, it never released that memory. It just held on to it, even if traffic later dropped. This became an issue for some of our internal Microsoft partner teams, like Azure App Service, which use Kestrel to actually handle billions of requests per day on their front end. After a traffic spike, they would see a spike in memory usage that would just stay stuck at that high watermark. So we've been working with them on this problem for a little while now. We've tested various approaches with them in production on how we could improve this. And the chart that you see on the screen shows the new behavior. Unused memory, as you can see, is being evicted, and the total amount of memory is going down, which is what you want. So this is great for hyperscale services like Azure App Service, but it's also great for all of you. These improvements are now built into the framework in .NET 10 Preview 6. You get them by default. You don't have to change anything. And I think this is really a great example of how Microsoft's experience using ASP.NET Core at scale results in platform benefits for everyone. You get better scaling, lower idle costs, and smarter resource utilization thanks to these improvements. Next, I wanted to share some updates about our validation support, the new validation support that's in .NET 10. You may have seen previously that we added support for validation to minimal APIs in earlier .NET 10 previews, and that included support for validating nested complex models. Well, these validation capabilities are now available for Blazor too. This means you can now validate nested complex models in your Blazor forms, just like you can in minimal APIs. We've integrated this new support into the existing data annotations validator component, so you can use it to validate your models in a familiar way. Both minimal APIs and Blazor use a shared validation implementation, which we've now moved to Microsoft Extensions.validation. The validation APIs themselves are currently still experimental in .NET 10, but the validation functionality in .NET 10 that's used by Blazor and minimal APIs will be fully supported. So I thought I would show you that. Let me show you some of the validation improvements. So I've got here this is an ASP.NET Core app that has both minimal API and Blazor logic wired up in it. Below, we can see our single minimal API endpoint. It's just map post endpoint, which takes in an order model. And if we go to the definition on that, we should be able to see what that model looks like. And here it is. And this is a fairly, complicated model. It's got, customer details, which is a complex type. It's got a list of order items, which are all, complex types themselves. If we look down at the customer model, it's got, a shipping address. And then if we look at the orders, they have their own properties too. So, deeply nested structure. And you can see that we've annotated all these properties with various, validation attributes, various data annotations to say how this data should be validated. And we can test this now with our minimal API. Like if I have an HP file set up here, and if I just go ahead and send a request, this is a valid request, so it doesn't have any validation issues. And you can see we got a 200 OK, which is what we want. If I do some mangling here, though, of the data, like let's make this no longer look like an email address, and let's request an excessive number of widgets. And if we resend this request, you can see now we get actual validation errors for minimal API. So an invalid email address and an invalid quantity for that property. That's shipped before. That part's not new in .NET 10 Preview 6. But what's new is that in this app, let me undo those changes. There we go. In this app, I also have a Blazor component, this home page, which has a Blazor form on it. And it's using the normal Blazor data annotations validator component. But this component has now been enabled to do complex object graph validation without any other change to the form. The data annotations validator previously would only go like one layer deep, like it would only validate your top level properties. This has been a long-standing ask in Blazor. I think at one point we even had a separate validator component implementation, like an object graph data annotations validator component that shipped in preview, but it never shipped a stable version. This functionality is now built in to the existing data annotations validator. And below you can see we're displaying all the validation messages associated with the model. To light up this functionality in the data annotations validator, you do need to make one change, which is just to turn on the new validation system, which is this API call right here. In Program CS, just make sure you call add validation, and then that new functionality will light up for your Blazor forms. I think I've got that form already running over here. Yep. So if I go ahead and try to submit this form for that order model without making any changes, you can see that everything is currently invalid. And as I start typing in data, let's order some pizzas. This will be for me, and Dan@example.com, an email address. If I had messed up my email address, I get that same validation for email addresses that we saw before. Let's send this to Microsoft. And I think this is the zip code. Yep, looks good. And what should we order? Let's order some Hawaiian pizzas, which I know is controversial. So we'll say, hold the pineapple, and that looks good. And so everything is now valid. If I instead, put in I want 120 Hawaiian pizzas without pineapple, then I get my validation errors as well. So this all looks great. I can submit, and it's a fully valid form. So that's complex object graph validation that's now enabled for Blazor using the same exact validation infrastructure that we're using for minimal APIs, new in .NET 10 Preview 6. Right, so that's the new validation. Next, we've also added support for WebAuthN and Passkeys to ASP.NET Core. This is something we've been working on for a while. If you're not familiar with Passkeys, Passkeys are cryptographic credentials that replace traditional passwords. And the great thing about Passkeys is that they're phishing resistant, they're easy to use, and they're secure by design. Passkey consists of a public-private key pair that's scoped to a specific account and origin. The private key is typically stored in an authenticator app, like it might be Windows, or it might be a separate device, or a hardware-based key. And the authenticator handles verifying the user identity before allowing authentication with a stored passkey. So that's how it works. We've been adding built-in support for passkeys to ASP.NET Core Identity. We've been taking a lot of inspiration from the open source 502 netlib library, which is a really great open source project, and we've been working closely with that project's maintainers. We plan to support both resident and non-resident keys, but we don't plan to support attestation for the authenticator in .NET 10. So that's one area we don't plan to handle, at least not yet. In .NET 10 Preview 6, we've already updated the Blazor web app project template to add the passkey support when you enable individual user accounts. We plan to also update the Blazor identity scaffolder as well in the future update. For your existing projects that are perhaps already using ASP.NET Core Identity, we will, of course, provide guidance on how you can manually add the passkey support. So let's take a look at this. Let's try out the new passkey support in .NET 10 Preview 6. So let me go ahead and create, I'm going to create a new project from scratch. Let's create a new Blazor web app, and we'll just use the project template here. Let's call this Blazor Passkeys. Is that name used yet? Looks good. Okay. And I'm going to say that I would like to use individual user accounts, which now has the new passkey support. I'll leave all the rest of the default settings. Now we'll create me a project template that will include all of the component code for setting up ASP.NET Core Identity. And as you can see here, there's even, let me zoom in a little bit. You can see that there's some added code now for dealing with passkeys. So let's go ahead and get this running so we can see what the app looks like. Usually just take a second for this app to build and get executing, but then we will try setting up a user account with this application that has a passkey instead of using those old usernames and passwords that you easily forget and can be easily fished from you. Okay, here's the app. So I opened up on my other monitor. Now let's go ahead and register a user. Let's see, let's do me, and I'm gonna start out by doing it the old school way, right, with a password. And we'll go ahead and register that. Now, initially, I need to set up the database with the database schema. So this should give me a page that says, hey, the database isn't there yet. Do you want to set that up? Let's give it a second to figure that out. Yeah, okay. And so in order to set up the schema, you just need to apply the Entity Framework Core migration. So I'll go ahead and do that. And now when we refresh the page, we should see that we have a registered user, and we can click on this link to simulate the email confirmation. Okay, so now if I log in, and we use my username and password initially. If I go to my user account, you can see we now have a section for passkeys. And so I can add a passkey to my account. And now here, this is my authenticator app, right? This is Windows saying, hey, this browser wants to set up a passkey. Let me first make sure that it's you, Dan, that it's not someone else. So it's asking for like my, a PIN in this case. It could use a variety of techniques for doing that verification. And you can see Windows has now saved a passkey associated with my user account for this origin that I can now should be able to use to log in. And I can give that passkey a name. Let's just call it Windows and save that there. Good. So now I have a passkey. If I wanted to add additional passkeys, I could. Like you could see, I have options for adding a passkey that's stored on like, my phone or a YubiKey like style device or whatever. But I'm just going to use the one that I have currently on Windows. All right. So use that passkey to log in. I'm first going to log out. And then you can see that down here, there's the option to log in with a passkey. And here Windows says, well, what passkey do you want to use? Let's use this one. And it's going to, again, verify that I am who I say I am, that it's not someone else trying to log in with this passkey. And voila. So now I'm logged into my Blazor application using the new Passkey support. Okay, so it's just that easy. That's available now in the templates in .NET 10 Preview 6, and we'll be adding it to the Blazor Identity Scaffolder as well in a future update. Much better authentication. It's pretty nice. Okay. Lastly, the thing I wanted to show you is that one of the really big investments that we've been making in Blazor for .NET 10 is support for state persistence. Now, what is this all about? So Blazor today actually already has support for persisting component states when you're pre-rendering your components. So pre-rendering is when you browse to a page, and instead of waiting for the WebAssembly runtime to be downloaded or for the circuit and the WebSocket connection to be set up, you just go ahead and render some HTML directly from the server into the server response. You're pre-rendering the page, so you get HTML down to the browser as fast as possible and a much better initial load experience. Now, sometimes when you do that, you often want to take the state, whatever state you used to pre-render the page, you want to reuse that state when that page then gets set up for interactivity, either using WebAssembly or using the interactive server model. If you don't reuse the state, you can end up with sort of flickering patterns, and it's just wasteful, right, to hit the database twice to request the same data. So we've had support in Blazor for a while for dealing with that problem, for persisting that pre-rendered state, and we have this imperative API called the persistent component state service that you can use for saving some data into the page that can be reloaded later. It was a bit tedious to use, and so in previous .NET 10 previews, we actually added a declarative model where you can just attribute a property on your component and say, "This is my component state. Take care of the details for me." And it involves much less code for you to persist your pre-rendered state. So that's already shipped, and was kind of the first step in this Blazor state persistence journey for .NET 10. Now, on top of that support, we also want to improve the resiliency of your Blazor server apps by giving you the option to persist your circuit state when the client gets disconnected. In Blazor, when a user disconnects for an extended period of time, and this can happen like if they're on a phone and they swipe away from the browser and put the browser in the background, often when you do that, the browser will like kill all the connections because, you know, it's sitting in the background. It's not currently doing anything. Might as well save on power, might as well save on resources. But then if the user, you know, comes back, say 10, 30, 60 minutes later, Blazor, well, when that disconnect happened, Blazor will have a state on the server, and it'll be like, well, the user just disappeared. They're no longer connected. It will wait a little while, holding on to that server state, holding on to that circuit. But if the user doesn't come back within a certain timeout, and by default it's like 3 minutes, it just evicts the circuit. It kicks it out to save on those server resources. So if you have a user that, you know, disconnects from the app for a prolonged period of time, they might come back to the app and they've lost all their state because the circuit is now gone. In .NET 10, we really want to improve on that experience. So what we're doing is we're giving you the ability to automatically persist the state of your circuits before they get evicted. This means that if the client reconnects after a prolonged period of time, the app can then restore that state, and the user can then resume the work uninterrupted. Okay, so they can swipe away on their mobile phone, go to lunch for an hour, come back, swipe back, and then you can reload the state that was persisted by the server when that circuit initially got evicted, so it can be effectively resumed. So that's you know, improved resiliency. That is now available in .NET 10 Preview 6. And I'll show you that in just a second. The third piece of Blazor state persistence is also improving scalability. You know, each of those circuits that you hold on the server is taking up server resources. Some of the circuits might actually not be actively used, and so you might want to free up those circuits by persisting them and then reload them later when they're actually needed. Now, this is not something that we are planning to do automatically for you in Blazor and .NET 10, but we're giving you the APIs so that you can implement an appropriate policy for your app. Like maybe, for example, if the browser is no longer visible that the user is using, might as well persist that circuit and free up the state because the user is obviously not using the app. Or maybe if the circuit is idle, like you detect on the server that nothing's happening on the circuit and it hasn't happened for like 10 minutes, you could persist the state and then rehydrate it later. Okay, so let me show you a little bit of what I mean. Okay, so let's go back to our Blazor Passkeys app, and we'll use this. And we have a little bit of an interactive server functionality in this application. Like if I go to the counter page, you can see I can click the count, and the count goes up. Now, remember I said that if the user disconnects from the server will hold on to the circuit state, the server state for a little while. By default, it's 3 minutes in case the user tries to reconnect. And if they reconnect within 3 minutes, everything's good. If they don't, then that's when the problems occur. Now, I don't want you to have to wait 3 minutes for the circuit to actually get evicted. So I'm going to do a little bit of a tweak to the app. Let's go in right here, and let's change this to set this setting. Let's make it a little bigger so you can see. So I'm just setting the disconnected circuit max retained to 0. That's basically telling Blazor, don't hold on to any circuits. Just evict them immediately if the user disconnects. Okay, so let's go ahead and restart that. So we get the new behavior, and that will allow me to simulate a disconnected user a little bit easier when I'm on like a live stream call. Okay, so that should now be running, and let's go back here. Okay, so what I'm going to do is let's make sure let's bring up the browser DevTools, and let's refresh the page. Okay, now let's make sure our circuit's working. It's working. Okay, so the user now has some state. They've clicked on the counter 6 times, and they don't want that to go away. That was an important number for whatever reason. Now, to simulate a disconnect where the client actually disconnects from the server, I can't exactly yank my network connection right now because we're talking. So instead, I'm going to use this internal Blazor API that's just for demo purposes. This is not something you should be using in your apps. But this is going to allow me to sort of force the browser connection to be closed just using the browser DevTools. Okay. Now watch what happens over here in the to my counter. That's empty cache refresh. Let me do that again. So I got some state, and let's force the connection to close. And you can see that it was very quick, but the browser detected that it was no longer connected to the server. It tried to reconnect. The server was still there, so it was able to reconnect. But when it did, the circuit was gone. And starting in like .NET 9, what Blazor does is it will just automatically like refresh the page and basically say, well, I'll start again and create a new circuit. So we lost our state. This is effectively what happens to like your Blazor server mobile users when they swipe away from the app for a long period of time. Okay, how can we fix this? So to fix this, what we're going to do, let's go back to our app, And let's go to our counter component. And I'm going to, instead of having the state just be in a field, let's update it now so that it can be persisted. So I've got this current count property, and now it's got this supply parameter from persistent component state property, which basically says this is state for this component that should be persisted. And let's update the component so it's fully compiles. And that should now allow us to persist our circuit and hopefully resume it. Let's see if that now works. All right, so we should be back up and running. And let me clear all the cache, make sure we don't have anything stale kicking around. And let's go ahead and get some state. Let's get, we're up to 10, okay? And then I'm going to kill the connection one more time. That same issue, I'm not sure why that keeps happening. Let me do that one time. Reset that, set the state. And you can see, so this time I killed the connection. The circuit on the server was evicted because we said, don't keep any circuits. When Blazor tried to reconnect, the server was able to basically reload the persisted state, and we kept our current count at 6. Okay, so that should help make your Blazor server apps more resilient. The other part of this is also making them more scalable. And to show that, I'm actually I'm going to use .NET Aspire and some of the new metrics that we've added in .NET 10. Let me close this app and let me go back to the Visual Studio. What I'm going to do is I'm going to enable Aspire for my Blazor app. If you've never used .NET Aspire with Blazor, you should. It's great. It really helps improve the developer experience. There is a little issue right now that .NET Aspire has not shipped support for .NET 10 yet. So if I try to do like right-click, add .NET Aspire orchestrator support, which is the easy way to add Aspire to your Blazor app, currently it'll say, hey, I can't find templates for .NET 10. So there's a quick workaround for that, which is just, I'm just going to downgrade this back to .NET 9 just really quick while I add Aspire support, and then we'll switch it back to 10. So now that should allow me to add Aspire. Great. And the .NET 9 version of Aspire works fine with .NET 10. They just haven't shipped the official .NET 10 support yet. And then let's make it go back to 10. Okay. And then I also want to use the new metrics in Blazor in .NET 10 so we can see what's happening to our circuits as we do something fun. So I'm going to go into this service defaults project in the extensions file, and I'm going to add some more meters. I'm going to add the Blazor meters, the Microsoft ASP.NET Core Components and Microsoft ASP.NET Core Components server circuits. And you can imagine that that's the one that's going to be really useful for us to see what's going on with our circuits. Okay, and that's it. That's how easy it is to add Aspire. So now let's get this app running. And this should bring up the super fancy Aspire dashboard, which, by the way, is also implemented in Blazor. And then we can see if we can make our app more scalable. All right, so look at this run. Build succeeded. Just waiting for the browser to pop up. So, well, like I was saying before, every time a user connects to your Blazor server app, you have to create a circuit, and now there's state on the server for each user that's connected, whether that user is actively using those resources or not. Like they might have started the app and then gone off to lunch. So what we can see here is if I bring up the app, and let's put this side by side with the dashboard. Here's our dashboard. In the dashboard in Aspire, we can go see all of our metrics really, really easily. So if I go and look at the metrics for my Blazor application, and then let's get a circuit going by going to the counter page. There we go. So we've got a counter. You can see now these metrics right here, these server.circuits metrics. Let me see how many active circuits I have and how many of them are actually connected to the user. I actually have an active network connection. And so if we look at this right now, we should see we have one circuit. And yes, that's what we have. We've got one. In fact, it's a little easier to see in the table. We've got one circuit. If I duplicate the tab, we should have 2 circuits. Yeah, now we've got 2. And if I duplicate again, I should have 3 circuits. So every time we get a new user, we allocate a new circuit, and we're using server resources. If I close one of these, it should go down once the browser. Yeah, there it goes. So now we only have 2 active circuits. And that's fine. But you can see that when I have these 2 browser tabs open, I'm only using one of them. I'm not using both of them at the same time. So is there really any point in having 2 active circuits on the server? No. So what I can do is let's add a policy to our app to free up those server resources when the app isn't currently visible. And to do that, let's go back here to our components, and I'm going to find the app.razor file, and I'm just going to add a little bit of JavaScript. This API is a client-side JavaScript API, but it's pretty easy to use. So here we have Blazor pause, and Blazor resume. And that's going to allow me to explicitly say, hey, server, go ahead and pause. The app's is not being used. Go ahead and persist the circuit state when you pause. And then resume says, hey, start it up again. And here's use whatever state was actually persisted. And we're doing this whenever the visibility of the app changes. So if the app is hidden, then go ahead and pause the app. If the app becomes visible again, then resume. Okay, pretty simple. Let's go ahead and hot reload that into the app. Let's close this down. We'll refresh so we get those changes. And now if we go back to the Aspire dashboard, so currently it should say we have one circuit. Yeah, we have one circuit. And now if I duplicate the tab, notice it doesn't change. Like I can duplicate again. Like it's still saying I've got one at the top there. You see that? I've got one circuit. But if I grab one of these tabs, let's make it visible by pulling it down here. So now I've got 1, 2 circuits. I'm not sure why it's saying 3. Is that because I think the third one might have popped into view momentarily. Can I close it? Okay, yeah, now we're back to 2. So we have 2 active circuits. And if I hide one of these tabs again, so now we only have 1 visible tab that should trigger the browser visibility notification. Yeah, there it goes. Yeah, so now we only have 1 circuit. Okay, you see? So as the browser is visible or not, you're able to save on server resources by pausing and resuming those circuits. Okay, so that's the Blazor state persistence features that's now available in .NET 10 Preview 6. Automatic persistence of evicted circuits that when the client gets disconnected, and then API so you can implement a policy for making your apps more scalable by explicitly pausing and resuming circuits. So that's just some of the stuff that's new in ASP.NET Core and .NET 10 Preview 6. There's a whole bunch more. I'll point you to the release notes to check out all of the new functionality. And that is what I've got for you guys today.
Dan, that's a ton of stuff. So as I was going through and helping with the release, so much of the stuff this release was .NET 10 Preview 6. Did stuff just kind of was ASP.NET for this release? It just kind of lined up that way?
I mean, yeah. I mean, some features take longer than others and take multiple milestones. So you might have kind of uneven distribution of the when the features ship on any given milestone. But yeah, this happened to be a fairly feature functionality rich release for us. And I think we have 1 more preview left, right? Like preview 7, I think is the last official preview for .NET 10 before we go into release candidates. And that's when we expect to be, functionally complete in terms of the, new features. Of course, we'll still be working on bug fixes and stuff after that and polishing it up, getting things ready for production. But that's where we're at. We're getting pretty close. So wrapping up those big features was kind of important at this stage in the release.
Okay. Well, I want to make sure we have enough time for Chet and Joel, but we've got 3 questions. So if we can go relatively rapid fire through these. Okay. Is there a way to set the same behavior without attributes? This was for your first demo where you're showing the validation support.
So the validation model here is based on system component model data annotation. So it's a data annotations based model. There is a low-level interface like iValidatable object or something like that you can put on the type that allows you to define whatever arbitrary validation logic you want for the whole type. So that's an option in that model, but it is primarily a declarative validation model.
Cool. Let me see. This was a question on the stateful persistence stuff. So a question about sticky connections and server resource use.
Yeah, that's a great question. One thing I didn't mention is when you persist, where's the state stored? So when the circuits get evicted and you're persisting the circuit state, by default, if you don't do anything, it'll actually store that state just in memory. So it'll be in memory on that server. So sticky sessions would still be important then because you need to be able to connect. You want to connect back to that same server to get that persisted state, just like you would with your reconnection logic if the whole circuit is actually still in memory. But what you can do is if you're using hybrid cache, which is a multi-tiered caching abstraction, which will do both in-memory, local in-memory caching as well as distributed caching, like with Redis, then the Blazor state persistence logic will just pick that up and use that instead. So then you could have state stored in your distributed cache, and it could be picked up from there. And then I think potentially in that case, the sticky sessions becomes less critical, but you'll probably still want it though. You'll still want it for like the reconnection case where the circuit hasn't been evicted yet, and you just want to come back to it. In general, I think sticky sessions are still to stay in Blazor server for a while. But what you save on is the number of circuits that you're having to keep in memory. Right. That can be pushed down.
Okay. One last question for you, and this is just about the supply parameter from persistent component state.
People don't like that. Actually, what do you mean? Yeah, we know. So this is actually being changed for preview 7. I believe the API when we defined this attribute, the engineer who worked on it, Javier, deliberately picked the longest, most obscene attribute name he could, because he knew when it went through the API review process, which we review all of our new public API surface area as a team and discuss like what's the right name for this, how can we make it as clear as possible, make it consistent across the whole framework. We do all that with each new API. He knew that this was going to have some debate. The API review is done for this, and I believe it's persistent state attribute is where we landed for this attribute. So there is a new attribute name that's coming in preview 7 that will be much shorter. So don't get too attached to supply parameter from persistent component state attribute. It will be getting a facelift.
Okay, awesome. All right, well, that was amazing stuff, Dan. I've got to bring on Chet, but thanks a bunch, and you've set a very high bar here for Chet to follow. So
thanks, folks.
Good luck with that, Chet.
I mean, right. I may not have supply parameter from persistent component state, but I have MSBuild Project XML.
Okay, that's pretty good. Everyone loves XML.
Everybody. Right. So, I mean, the XML is in service of what I think is one of the more unique features of the .NET CLI, which is tools. Right? There are lots of parallels for these things in different ecosystems, but the core idea is, wouldn't it be great if there was an easy way to distribute .NET binaries so that other people who have the .NET SDK can easily go grab them and run them? And they've been massively successful. Like you see this in Go, you see this in NPM, right? Yeah. This concept of my project provides some binaries that I can use to do X and easily get them and collect them and pin their versions and that sort of thing. Super useful.
And up till now, it's like you could do it, but it's not like kind of natively, right? It's like something you have to
they've been this kind of weird side thing. If you pop up my my screen, we can actually sort of talk about what makes a tool today.
Okay, just a second. Add to stage, and then I have to do a new thing here because there, and add to stage. I have to remove Dan. That was the problem. There we go. Okay. Awesome. So I'm going to disappear and you go for it. Okay.
Sounds good. So this is a tool as it appears today. Tools are what we call framework dependent, runtime agnostic binaries, right? So when you run .NET Pack and you have the pack as tool MSBuild project file property set, the .NET SDK takes over and builds your application, adds some additional metadata, and then shoves it in this format. And then later commands like .NET Tool install, global and whatnot, and .NET Tool restore will then acquire and make these packages and their contents executable by the end users. The key thing that makes a tool, well, there's sort of two pieces. One is this package type, .NET Tool, but just as important is this file called .NET Tool Settings XML. And the point of this file is to say that when we run this tool, or when you install this tool package, you will get access to this command, and you invoke it using .NET pointing at this thing. And all of this is orchestrated for you for free by the .NET SDK. We love our framework-dependent, runtime agnostic tools because they're easy to use. If you have a .NET SDK, then any tool available today that matches your target framework, your runtime identifier, or your target framework versions can run, right? They're very portable is what we say. But there are some downsides to this layout here. As anyone who has built a framework dependent application or a portable application before knows, this means when you bundle your application, you end up with a whole bunch of runtime specific assets. So if you've ever looked at a layout like this and you've seen the runtimes folder with a whole bunch of runtime specific bits in there for Linux x64 and Win x64 and macOS ARM64. You're carrying all of those bits for every single platform along with you. And no matter what platform your users are on, they're going to pay the download cost of every single one of those other platforms. And so we took a look at this structure and we said, we think we can do better. We think we can support platform-specific tools if we want. And that's the big headline feature of for the SDK and .NET tools in Preview 6 is supporting these platform-specific tools. What I've got here in this repo, this is a repo called Barenfell/multirid tool. This is a sample repo I've been working on. But we have a little program called toolsay that uses spectre.console to create some Figlet text. This is like ASCII art that you may have seen other tools use. If you've run the .NET Say tool or the CalSay tool, these are like in the same family here. But this tool is very simple. It lets you supply some text. It lets you pipe some text into the application. And if you don't specify anything, then it will use spectre.console to prompt you for some text. And then once you give it some text, it will output it, right? This tool doesn't have any runtime specific components to it, but I would like to make it native to Windows or native to macOS. Well, it's really easy in .NET 6. So assume I have all of this stuff set up for a normal tool. This is all just stuff that you do to make a good NuGet package. You give it a package ID, you give it a version, you give it some description metadata and a license. The big thing that changes in .NET 6 is now you can specify runtime identifiers for your packages. And if you do this, then you can run .NET Pack just like normal. And I'm going to use this tool type property because I've set this repo up to have a bunch of different kind of scenarios here to show you all the choices you have. But I'm going to skip to a simple one and just say, we're going to try the self-contained version of this tool. And when we run this, this is where things will start to get different because you'll see our sort of agnostic package, and then you will see all of the runtime specific packages. And if we go look in our package output folder, I said if we go look in our package output folder, there it is, you will see a bunch of other packages. So I want to take you through, I want to show you what's inside some of these. So the arrangement that you see here for these tools is the same name as we had before, now just with only our little mapping file in here. And if you crack these things open, this file now describes a mapping of .NET runtime identifiers to matching implementation packages for your tool. But what's in those platform-specific packages? Well, in this case, because this is a self-contained application, it will work. It has no target framework because it carries the runtime with it, but it is specialized for Windows x64. And so if we pop this open, we will see all of the DLLs that are by default part of a platform-specific executable. And there's our exe and the DLL it chains to and all the things. So this is kind of a chunky package, similar for ARM64 for all the other runtime identifiers I specified. But I just want to show you that this works great. So here I am, I'm going to run .NET tool exec. Our tool name is toolsay. And the source, I'm going to point to a local source in the artifacts package release directory. And this is the second new feature in .NET 6. .NET tool exec is a command that does sort of NPX style acquisition and execution in one shot. Right? So this is awesome because your docs or your getting started or whatever for your users can now just say .NET tool exec your package. So in this case, I want to run toolsay. I'll get a prompt so that it's not downloading things without my permission. And then it immediately went in to run my app. and there's my app run. And if I do this again the second time, there's no prompt because it's already locally available. And it works just great. This .NET Tool Exec works with any kind of package, not just these new platform-specific packages. So you should feel free to use it today as long as you've got Preview 6 installed. When we look at these packages, they're kind of big. Like there's no reason that hello world in some fancy ASCII text should be 30 megs. And luckily, the .NET Runtime team agrees with you because they've given us a whole bunch of tech that we can use to manage the size of our applications. And all of those tools are compatible with the new RID-specific .NET tools. So I've got the self-contained version that we just showed. There's a bug, so I can't show you the trimmed one, but I can show you the super awesome AOT one. So to make all of this work, you've got to have a sort of agnostic package and then specific RID-specific sub-packages. Well, you can make those RID-specific sub-packages through .NET Pack as well. So if we do our AOT tool type and use the new for .NET 10 Preview 6 runtime flag on .NET Pack, we can tell .NET Pack to AOT just the package for WinX64. This is kind of a quirk of the .NET toolchain. You can only AOT generally for the platform you're on. So that took a second, and it didn't take as long as it was supposed to because I forgot there's a bug in the SDK that'll be fixed in Preview 7. But if I blow that away and do the pack again, then we'll see it take slightly longer because AOTing applications does take a little bit longer. But then when we go look at our thing here, here's our package that we just made. It is only 1.8 megs. I want to make sure that you all see that. That is the beauty of AOT. And if we go look inside it now, it only contains the super small executable and the executable mapping that lets the .NET SDK work with it. So if we come back here one last time and I clear out my NuGet packages directory and I run this one more time, well, I'm going to have to make my marker package again. Do that real quick. Yeah, so we can see our agnostic packages back there. So we make that guy one more time, and then we do .NET Tool Exec one last time. Re-download it, lightning fast. AOT applications, baby. So I'm gonna pause for a second. The gist of what I'm trying to tell you now is the .NET SDK tools have more options, and you as the user can figure out where you want to land on the spectrum of options. If you are happy with platform agnostic, runtime agnostic tools like you have today, keep making them. Everything still works with them. But if you need to lean into native platform specific tools for whatever reason, we've got your back. You can do self-contained, you can do trimmed, all the way to AOT. If you do want to do AOT, you have to do a little bit of orchestration yourself. My repo has an example of that. Essentially, you just have to matrix over the different platforms you want to support and call pack for the specific runtime identifier to make the individual packages. So I've got an example here that shows all this. You have one step that builds all the platform specific packages, one step that builds the agnostic package, and then you can collect them all into a single artifact to publish up to NuGet. So that's the net new feature. But I wanted to show one last little awesome thing here. .NET Tool Exec, I hate typing it every single time. NPM doesn't have to do that. You can npx and run any tool you want, and it just feels natural. Why can't we do the same? Why can't I come over here and do something like this? Oh, it turns out I can, because we did that for you too. Starting in Preview 6, you can DNX run any tool, automatically acquire it if necessary, and then invoke it. Boom, done. It is so freaking awesome. and I love playing with it. And I really, really, really hope all of you do too as well. At this point, I will stop, pause, take any questions or comments or whatever that there might be. What are we looking like, John?
Unmute, because that's what we do. Okay, I got 3, but I want to make sure we have time for Joel too. So a few quick ones. One, Jimmy said, just kind of a thing to bring up here, but oh boy, now we have security issues. I did notice that you had like a prompt, right, that said before downloading. So what
Let's talk about security?
Yeah.
So definitely you have to provide positive affirmation to install these things, right? The second time I ran it, there was no prompt because it was already local. And that kind of pattern you'll see all over the place. If the tool already exists locally, we can run it. If it doesn't, then we have to ask permission to acquire it. We would love your feedback on whether or not to flow that through to non-interactive scenarios, meaning scenarios where tools or setup instructions or your CI/CD are running .NET Tool Exec or DNX. Today, even in like a GitHub action script using these tools, you're using .NET Tool Exec or DNX, you have to pass -y. NPM doesn't have to do that. Other platforms don't necessarily have to do that. Let us know how you feel. There's also the question of like managing versions and managing sources. All of these tools are NuGet packages. So if you have a NuGet config that defines the allowable sources, and if you have package source mapping set up, all of those like traceability mechanisms work with tools as well. Finally, one thing I didn't mention is that .NET Tool Exec and DNX are sort of, they implicitly understand local tools versus global tools. If you are using a local tool config manifest to describe a set of tools, and you invoke a tool via DNX that you have in that manifest, we will automatically only use the version that you have in that local manifest. So you can pin the versions that DNX use through a local manifest like that, or via package at version syntax.
Okay.
Right. So you have a few options, and the idea here is to always do exactly what you tell us and no more.
Awesome. Okay, let me see. Do one more question here. If I install the tool on WinX64, it'll download that version only or other RIDs. I think that's what you're showing.
Exactly that. Yeah. So we navigate, we download that tiny top level package, crack into the sort of manifest that it has in there, and decide which of those packages is the best fit for the platform that you are on. So if we dig into this file, we've got Linux x64, Linux ARM, Windows x64, Windows ARM, and OS X. On my machine, this is the best one. And so that's why we downloaded just that package. And I can actually show you that. Code NuGet packages. We can see that just the top level package and the WinX64 package are present on my system. There is some interesting bits and pieces there. If you pack for a runtime identifier and it's not super specific, we will handle walking up the tree and find the most correct RID for the platform that you're trying to run on, right? So there's kind of a balance there. I've chosen these 5 runtime identifiers because they are the most broadly used across our ecosystem per our public telemetry data. But I mean, you can choose whichever set you want. And future enhancements to this whole feature coming in Preview 7 will allow you to mix and match these RID-specific tools as well as any RID tool, which is just the platform agnostic tools that you can make today. So you can have a built-in fallback to running non-native for platforms that you did not explicitly support. So look for that coming in Preview 7.
Very cool. All right. Well, I want to make sure we have some time for Joel. So let's bring him up. And I love this because Chet, this all works together. I was joking before we started. There's a lot of things releasing that all just kind of magically came together. And so you showed off DNX, which is really cool. And then Joel's going to take it to the next level, I think, here. So,
Yep.
all right. Thanks a bunch, Chet. We'll kick you off, and we'll get ready to see some Joel awesomeness. So, Joel, let me go ahead and I'll share your screen, and I'll go ahead and disappear. And
Cool, thanks.
Let's see what you got.
Yeah, so what I wanted to share is a new package scenario, a NuGet package scenario. Essentially, it's packaging MCP servers inside of a NuGet package. So if you're not familiar with MCP, it's a protocol introduced by Anthropic to basically augment your Copilot agent or your LLMs with knowledge not in the base model. So there's a whole ecosystem already out there of MCP components, often written in JavaScript or Python, but there is a SDK for writing MCP servers using C#. So what I'm going to show here is how we released a new template so you can get started and create your own MCP server, and how this can be packaged into a NuGet package, pushed to NuGet.org, and then consumed and used inside. We're going to use VS Code to consume the MCP server. So yeah, I'm just going to breeze through this real quick. So we have a new template. There's a quick start guide, which you can find on .NET Docs. I'm just going to install that template real quick, and it'll tell us which templates were installed. So we have this new MCP server. So we're going to just create a new one. Oh, I didn't. Yeah, okay, great. CD sample MCP server. And let's take a look at what's in the template, what we set up for you. So we have a CS proj here. And this kind of plugs into what Chet was talking about .NET tools. Essentially, this isn't a locally running .NET tool, but inside of it, it's running the MCP protocol. So basically, it'll start it'll be a running process, and then your local agent will talk to this server and maybe call out and do your whatever special features you want for your MCP server. So I'm looking at a CS proj here. I just wanted to call out a little bit here. So this is Package tool. This has been here for quite a while in .NET. What's new is we're adding an additional package type. We're saying this is a .NET tool, but it's also this additional thing, this additional new thing called an MCP server. And we have some package metadata set up. But let's look at the code. So this uses the SDK, the C# MCP SDK, pretty simple entry point. But I wanted to call out, it sets up some tools. And so what these tools are these are the tools that your AI agent can call once it knows about this MCP server. And I'll just show very briefly. This is a boilerplate tool. It just generates a random number. So what I'm going to do is I'm going to run this MCP server locally, invoke it using VS Code, and then do the NuGet parts a little bit later. So let's just get some config here to use the MCP server in VS Code. So I'm going to do .vs code, and then there's a mcp.json file. So I'm going to paste this here. This is basically saying this Copilot agent will look at this config and know of this MCP server. So I'm going to just do relative path is current directory, because my workspace is this root directory here. And I'm going to make sure that the server can start. I'll just hit start here. Looks like it's running. It's running. Do we have any tools? I think so. Let's check. Oh, it says one tool. Wonderful. And then I can click this to see what tools it's discovered. It's found my get random number tool. Wonderful. So I can say, all right, Copilot generate, no, how about 2 random numbers? Let's shoot for the stars. We'll just do that. And what I'm hoping it does, yeah, it says, okay, I want your permission. The Copilot saying, I want your permission before I call out and do something, because these tools internally run arbitrary code, right? They run .NET code. So I'm going to hit continue. Yeah, it's generating a random number from 0 to 100. Seems fine. And it's running it again. Seems fine, because I asked for it twice. And it did 61 and 25. So what it did there was invoke this method via the MCP protocol. And internally, it's generating random numbers, and it's showing them back. Okay, so this is existing behavior with the C# MCP SDK. What we've added is this template and the NuGet.org side. So I'm going to pack this up and .NET pack. And it will create a NuGet package in the release. I think I can actually do it here. Yeah, there's the NuGet package. So what I can do is I can now publish this to NuGet.org. And we've enhanced the browsing experience for MCP servers. So I'm going to show that now. This is a little bit later in the guide. So I'm going to go to NuGet.org, and we have this new filter, package type filter for MCP server. As I showed before, this string was defined in our CS Proj MCP server. So that's where that's coming from. So now this is filtering all the MCP servers on NuGet.org. It happens to be one because this is just releasing today, and it says unrecognized because we're still enabling the filtering feature. But if I click on this, you'll see, oh, okay. So there's a new tab, MCP server. And so I'm now, imagine I'm no longer the author of this MCP server. I'm someone that's interested in consuming an MCP server and augmenting how I use AI in my dev loop. So I have this config, and what I can do with this config is use this in VS Code to call out using DNX, which Chet talked about before, to pull in this specific package version and launch the MCP server. So I'm going to just copy this guy. I'm going to paste that in there. It looks like, yep, that looks right. I'm going to start a new chat window. And you'll notice to the point about the yes parameter that Chet was talking about before, we've supplied it here because we believe that the explicit action of copying and pasting this into VS Code is essentially providing the yes, but we want feedback on this, of course. So this is going to download that package of this version and launch it with some parameters. So I'm going to hit start. It looks like in this MCP server, I have some inputs configured. This is weather choices, so I'll do hot or cold. Sure, why not? And then now let's see what tools are available in this MCP server. There is city weather and random number. Okay, so like what is the weather in Cincinnati, which is the city I live in? And it's, again, prompting me because I should know what my agent is doing. And it's saying it's hot, which is one of the values I provided in the input, just to show that you can plumb configuration into your MCP server. I think that's pretty much all I wanted to demo. I would love to get feedback on this whole experience. There's this quick start. John Galloway, who opened the talk, has a blog post out. And I think there's a feedback link in there. But anyways, I'm really interested to see what MCP servers people build in .NET.
This is awesome. Thanks, Joel, for joining us for this. And yeah, this was an amazing thing that kind of came together because we've been wanting an MCP server, and then Joel said, "Hey, I got this thing started," and NuGet team had something going, and we had DNX. Like all arriving at the same time. So it's just beautiful to see it all come together. I'll share my screen super quick, just to show off that that post. So share, let's go with the entire screen, and here we go. So, and yeah, so here's the post. So John Douglas, Joel and I collaborated on this. John Douglas wrote most of it, but we all, and then the team, of course, all reviewed. But this is a walkthrough on how to do it. Important things here. You'll do this this .NET new install. Let's blow the page up a little bit. So it's .NET new install, the same way you install like Aspire templates or whatever, right? And then walk through on how to do that. And then the thing that I wanted to point out is down near the end, and I slapped it in here right near the this went out right as we were going live, but there's a thing here for this survey. And as Joel pointed out, this is a first release of this template. So we really want to hear from you, how you're using it, what sort of scenarios you'd like to see, that sort of stuff too. So yeah. So anyways, this is amazing. Totally appreciate it, Joel. Thank you for the great demo. I didn't see any additional questions here, so I think we can probably go ahead and wrap up. So, all right. Thanks, Joel. Thanks everyone for watching. We'll play the outro music and we'll say goodbye. Thanks, folks.